All right, so what we're going to look at now is we're going to look at solving equations and do a review of solving equations. Now, before we can get to solving equations, let's ask ourselves, what is an equation? Well, in math, it's pretty simple. If there's an equal sign, then we have an equation. So if we have something that says 2x equals 10, it's this equal sign that tells us we have an equation. And if we have an equation, to solve an equation, the final answer is also going to equal something. So if your equation at the beginning has an equal sign, at the end we're usually going to have an equal sign. Or as we'll see later, we'll be able to answer a question, what does something equal? It equals this. That's what an equation is. So let's review solving equations. First one we're going to look at is a very simple equation. Now, often an equation is going to have some variables in it. Remember, variable is just the letter, and we want to solve this equation. Now, to solve an equation, what we always have to do is isolate for the unknown, or isolate the variable. And remember, isolate is just get it all by itself. So we have 5x equals 35. If we want to isolate x, get x by itself, we need to split apart this 5 and the x. And remember, we do that by dividing by 5. If we divide both sides by 5, 5 in the top and the 5 in the bottom here are going to cancel each other out or divide each other out. And we're just going to be left with x. And 35 divided by 5 is just 7. So our original equation had an equal sign. Our final answer has an equation. Equal sign, I should say. It is an equation as well. Well, what if we have a fraction as an equation? Again, we want to isolate for the variable. In this case, the variable is a. Now, if we have fractions, we want to eliminate the fractions. We want to get rid of the fractions. And remember, we can get rid of the fractions by multiplying by the lowest common denominator. Now, since we only have one fraction in this case, the denominator is 3, the lowest common denominator would be 3. So what we do is we multiply both sides by the same number, both sides by 3. And when we do that, we'll have a 3 in the top and a 3 in the bottom. They're going to divide each other out, leaving us with just an a. And on the other side, 9 times 3 is 27. So that's what we do if we have a fraction. Just multiply by the lowest common denominator. Now, third example here. What if our variable is in the denominator or is in the bottom? Well, this doesn't change our rules. We just have to do a little different. This time we have to multiply everything by n. So when we multiply everything by n, what that's going to do is get rid of the fraction. So we multiply this side by n. I'm just going to put it in brackets so we know it's multiplication. And multiply this side by n. What's going to happen is we have an n on the top and an n on the bottom. They're going to cancel each other out. And on this side, we're just going to be left with -6, and on the other side, 2n. Now it looks like an equation at the start. Now remember, it doesn't matter which side of the equation the variable's on. We can leave it where it is, and we can divide both sides by 2 to isolate for that variable. On this side, if we divide by 2, we're left with just n. And on the other side, we have -6 divided by 2, which is -3. Is going to equal n. And when we give our final answer, n is going to equal -3. There it is. That is our solution to that equation. What if the equations get a little more complicated? So let's review solving more complicated type equations. Now, the technique and the method does not change. Solving an equation just means isolate for the variable. So we have to do algebra and do whatever it takes to get that variable all by itself. So our first equation, we have 3x minus 10 equals 8. What we have to do is we need to get the x all by itself. So we need to first start by getting rid of this 10. And remember, to do that, if we have minus 10 on one side, we need to add 10 to both sides. If I add 10 to both sides, what I'm going to get on this side is just 3x. If I add 10 to the other side, 8 plus 10 is going to give me 18. And now it looks like an equation we did before. We need to divide everything by 3 so we can isolate for x. On this side, we're just going to have an x. On the other side, we're going to have 18 divided by 3. So x is going to equal 6. Same thing applies in the next example. This time we have to use the distributive law and distribute the number in first and then solve the equation. So remember the distributive law? We multiply everything on the outside by everything on the inside. We're going to get 5a minus 5 is going to equal 3. We add 5 to both sides. And when we add 5 to both sides, on this side, we're just going to have an 5a. And on the other side, you're going to have 3 plus 5, which is, oh, let me just correct that mistake. There should be a equal sign, not a plus. This is going to equal, adding 5 to both sides is equal to 8. Now, I apologize for the writing getting a little messy, so I'm going to try and write that again a little neater. 5a is going to equal 8. Now we get to this point, and we need to isolate for a, so we divide both sides by 5. And what we have is a is equal to 5 over 8. Now, we can't simplify that fraction, and we don't want to convert to a decimal, especially in the rest of grade 10, unless you're asked to. So we're just going to leave it as a fraction. A is going to equal 8 over 5. It's not a pretty answer, but it's perfectly fine. Well, what if we have a variable on both sides and a number on both sides? Well, all this does is just make us do a couple extra steps, but it doesn't change anything. So, if we have to get the a by itself, first thing we'll need to do is move everything that's not an a to one side and everything that is an a to the other. So I'm going to start by moving 8 to the other side by adding 8 to both sides. Now if I add 8 to this side, negative 8 plus 8 is just going to leave me with a 5a. And I'm starting to get happy already because there's only an a on that side. On the other side, 2a, 5 plus 8 is going to give us 13. Okay, now we have an a on this side and just a number on this side, so we're halfway there. Now we need to subtract 2a from both sides. That way we can get all the a's on the same side. 5a minus 2a is going to leave us with 3a. And on this side, negative 2a minus 2a is going to be 0, and we're only left with 13. And now we want to get a by itself, so we want to isolate for a. So we'll divide both sides by 3. 3 on both sides, top and bottom here. And we're going to have an a value equal to 13 over 3. Again, perfectly valid answer. We can't simplify that. We're just going to leave it as an improper fraction. Last thing we're going to review is, when do we use all this? So we're going to look at an application. So here's a question for you. And it says, precipitation is moisture that falls in the form of rain or snow. The relationship between the depth of the rain, R, and snow, S, that results from equal quantities of precipitation is R divided by S equals 0.1. So what I'm going to do is I'm going to first write that out and get the information out of the word problems. Now, when we're doing word problems, first thing we want to do is not be scared by word problems. There are going to be lots of word problems. This is the key to the word problem right here. We're given an equation. We're going to take that word problem, we're going to convert it to a math equation. And in this case, we like the word problem because it gives us the equation. So we have R divided by S is equal to 0.1. There's our equation. And R, we're told, is the rain and S is the snow. So let's look at our question. if the storm delivers 15.5 centimeters of snow, what depth of rain would result from the same amount of precipitation on a warm day? So what is this little piece of information right here? Well, it tells you it is 15.5 centimeters of snow. The S is the key. So our S in our equation is going to be 15.5. That's all we do. Just replace the value with S with 15.5, and we're going to get R over 15.5 is equal to 0.1. Now it looks like an equation we've solved earlier. We want to get R all by itself, so we need to multiply both sides by 15.5. And 15.5 on this side, it's going to cancel out with the one in the bottom, and we're going to get an R value equal to 15.5 times 0.1 is 1.55. Now, with a word problem, we always want to write the answer out as a sentence because it's given to us as a sentence. So, the amount of rain would be 1.55 centimeters, period. There's my answer. That is a application of using equations. Now you can go on and do the practice questions for solving equations.